Good morning to all. This is Sudarshan Reddy, lecturer in Triple E, JNGP, Ramantapur. Now, here we can go for the speed control of motors. Here, speed we want to control the speed. Already we have discussed about the speed control of DC machines. Now, already we are controlling the DC motors. What is the need of once again we want to control the AC motor? We can use it only the DC motor means some advantages and some disadvantages it have. When already we are controlled from the converters, there is a AC to DC converter, that is a control converters we are used, and chopper controls also we are used by using the chopper control and AC to DC converter, that is called rectifiers we are used to control the DC motors. Already we are controlled means we can control. Efficient control will be chopper control, that is also we are used. Means whenever you can control that speed maximum range means we can control it. That's why generally major applications you can use the DC motors. Means we are already control that speed, we want to go for this AC motor means some advantages here and what are the drawbacks there, means what are the advantage there we can discuss here already. DC motors is just predominantly used in the industries. Generally we are used for the industries because there are numerous merits means advantages, that is construction, speed control over wide range. We can control whatever this construction also easy construction, and control speed control will be wide range. Over a long range we can means whatever the wide range we can use to control the that whatever the this DC machines. I starting torque means it have starting torque will be more, means easily it will be start. Whenever the starting torque will be more, automatically easily it will be starts. Why? Because it will overcome the inertia of the starting of the motor. It's simple. This is whatever the design, it will be simple. And expensive speed control means there is also one more thing will be, one more will be in the DC machines. However, this drives suffer from the what are the drawbacks. Why you go for the DC motor separate drawbacks it have, means some drawbacks it have. That's why we are going for this AC motors. What are the drawbacks? Means high maintenance cost, means high maintenance cost, and bulky construction will be bulky, and commutator and sparking. Commutator sparking we are mentioned. Commutator, every time commutator problems will be occurs, and where brushes the sparking will be occurs. Whenever you want to operate high, sometimes high range of speeds means high range of power applications, the commutator action will be the sparking will be occurred at breaks. Means there is a main problem in the that means not only that one, when the saturation of the that commutator will be occurs some applications. So we are not using the DC machines in the all the applications. Means present day we are using, but some applications you need to overcome the drawbacks. Means we are generally to overcome that what are the brake commutator problems, parking problems, means want to operate control also we are not using some applications in the DC motors. Means that the main drawback will be commutator and sparking and maintenance also. These are the major disadvantage of this DC machines. So to overcome that one, but we can control it wide range. That is a major advantage on the wide range of operation we can operate. Means a starting torque also major advantage. Why? Because so we starting, if it starting torque will be not more, it will not easily overcome that inertia of the machine. Means whenever starting torque will be more, it will be easily it will be started the starting of that motor will be possible. So here that is the major drawbacks of the DC motor. That's why we are going for the AC motor. Here due to disadvantage, generally we are designed the electronics. When electronics will be entered into the in the enter into the industries, means in not only industry means here development, that electronics will be overcome by the that will be means that electronics will be due to recent this electrons when entered in the technology, that electronics technology used to control these motors. Means that is what's due to recent advances the in power trans device, the AC motors are fast becoming as economical, fast becoming economical and efficient as compared to DC motor. Means control will be, we can control easily, we can operate easily, means it don't have the commutator problem or sparking problems. Extra simple construction also it have. Due to that one, there is a major advantage. That's whenever control major problem will be controlling previously, but whenever the polytrons will be entered into the technology, that that used to control this AC motors, that is used to control this AC motor is economically we can control, means wide range we can control. That's why generally we are overcoming the what are the drawbacks in the that DC machines we are fulfilling here in AC motor. That's why generally we are using this AC motors. Next, an AC drive system uses either an induction motors or synchronous. Means AC motors only we have the only means three phase systems generally, induction machines and synchronous machines. Induction motors or synchronous motors. Or most of the AC motors generally industry generally we are using induction motors only. Some applications only we are using the synchronous, means where is the constant speed required. At synchronous speed, at specified speed is required, the synchronous speeds, synchronous machines will be we are using. Other than the what are the synchronous, other than synchronous speed means lower than the synchronous speeds, generally major applications we are using induction motors. Means that's why generally these are the we are moved into the AC motors to control the AC motor. When the AC motors operates at directly online voltage, cause it may run at constant speed, means it will be run constant speed, but it is below the synchronous speed. Means we can know about that one, means we can operate below the synchronous speed, means it will be constant speed, it is below the synchronous speed, and with use of power electronic device it can run at speeds as we desire. Means by using we can design that power electronic design device to control at whatever the desired speed we can operate by using this power electronic device. Means that is a major advantage in the this means changes in the that AC machines, means automatically before we are not varying the this speeds in the AC machines, only we can wide range of control will be possible in the DC machines, only we are using the AC machines. Whenever this fast control acting in the AC machines whenever is implemented, means this is a more advantage compared to the DC machine. Why? Because DC machines have sparking and commutator, next complex of the control and maintenance problems. These all are the problems will be in DC machines, but control will be possible. Major, that is the advantage, that is the more disadvantage. That's why always whenever this technology is entered into the field or we are using AC motors. Means AC machines generally we are used to control the speed range up to wide range. Wide range of speeds we can use it. Now the induction motor is practically a constant speed motor. Means it is below this speed. Generally we are already discussing. It that means for entire loading range. Entire loading range there is constant speed. Means whatever the speed is happening nearly means small change will be occurs. Means that is a neglectable value. That's a neglect 1 to RPM or 10 RPM means that is how we are operating 1400 RPM means 1440 4060 mean 1440 RPM means the 40 RPM is just 400 means just that is a small value we are considering. Changing the speed of the motor is quite small due to that loading range. Speed of a DC shunt motor can be varied easily with good efficiency. But in case of induction motor, speed reduction is accomplished by corresponding loss of efficiency. Whenever you are operating the speed of the DC shunt motor, the speed can be varied easily. But efficiency with whatever the efficiency we are not losing that efficiency, we can vary that speed. But whenever you are entered into induction machine, whenever you are reduction in speed reduction will be possible, that automatically that efficiency will be decreased. That efficiency decreased at a time when our speed will be reduction, means due to that one some voltage detected, that whenever the speed will be detected, that efficiency will be decreased. Not only that one, power factor will also decreased. Means that's why we are not operating at less amount of the speed, less value of the speeds. As induction motors are widely being used, their speed control may be required in the many applications. The speed applications will be required, speed control is may be required. There are many applications. That's why generally speed applications we are implementing, means widely generally these are major applications industries. These AC machines generally present ACR is no. That's why we can apply that one. What is the advantage of this one? Here we can see that ruggedness in construction. Rugged construction means easily we can very rugged construction means ruggedness will be more automatically wherever it is used, we can use it. means a lower maintenance cost. There is a maintenance cost will be very low. Means not required that much maintenance is for compared to the DC machines. That's why we can use it this higher reliable operation of the this induction machine, higher efficiency. Why? Because it's an early we are operating on the rated speed only. Means continuous load changing, whenever load changing also it is a near small changes will be occur, but it is a not considerable value. That's why constant speed it will be operated. That's why it's the efficiency also output will be giving more that same amount of the output, means automatically the efficiency will be higher. Next, able to operate in dirty and explosive environment. Means whatever the dust particles, whatever the means explosives, whatever the gases, different locations also we can operate. This will not affect the that motor operation. That's why dirty in dirty places also we can explosive areas also we can operate. Means that type of any generally majorly different type of environments this motor will be operates. That's why generally this is a major advantage. In suppose we are considering the DC machines, whenever the dirty will maintenance is every time maintenance generally maintenance is required, but whenever the data available means automatically the every continuous maintenance is required. Explosives also whenever it causes in the DC machines means sparkings already it has sparking. Due to explosives, total sparking will be occurs in that machine. But it is not occurred in the this induction machine. Means that AC machines. Here cost also less compared to DC machines. Weight also less, and volume size also generally volume is size also less, and inertia of the machine also less. Why? Because whenever you are using the this AC machines, it's why we are maintaining the inertia. Inertia why? Because here inertia more means starting torque will be less compared to the DC machines. Whenever starting torque will be less means inertia more we are maintaining means automatic starting problem will be arises. But here the inertia will be less. To means automatically there is whenever the starting torque will be less also there is no problem to start this type of machines. That's why always you can easily can start the this machines as easily start easily compared to the this DC machine. Means DC machines have size also more somewhat, means volume also size more, weight more, means due to inertia is more. Not only that, whenever it when in the DC machines the torque starting torque will be more, it is no there is no problem about that starting. But here also starting torque will be less, means if make a create the problem of the starting. But so that's why we are maintaining the inertia will be less to automatically that sufficient torque will be starting torque will be developed to start the that motor. Means inertia loss, means there is a major advantage of this induction AC induction motors generally we are using. These are the major ruggedness in construction, lower maintenance cost, high reliability, higher efficiency, able to operate in dirty and explosive environment, lower cost, weight and volume and inertia. These are the major advantage of the this induction machines. That's why generally we are using the this induction machines in the industries different applications. Means automatically we have the this variable speed required, means that's why we are using the pultrons device used to control the wide range of speeds in this induction machines. Now here, what are the types of induction motors? These types of induction motor means here the two types of induction machine means they are mainly classified into two types depending on their application. Motor different drives generally we are using. Here first one will be adjustable speed drives. Second one will be servo drives. Here first one will be adjustable speed drives. Means here this type of drives are mainly used in industries. Adjustable every time it is speed is required. Separate speed will be required for the separate applications that you want to provide. Means that's you need to adjust the speed to the required speed of the that application. Means you want to control the speed, means that's why we are using the two types. So one is adjustable speed drives and next one will be servo drives. Here adjustable speed drives means in this type of drives are mainly used in industries industries for process control, used in the industries for process control. It can be achieved by controlling the speed of fans. This is used in industries for process control. It can be achieved by controlling the speed of fans. Means if you can control the what are in industries, you need to control the fan speeds and compressors and fans. The speed we can control. Adjustable speed drives means compressor speeds, what are the industry compressor of the industries we can control. Pumps speed we can control, fan speed we can control. Means blowers means we size blowers generally we are using the compressors or pumps, what are the size means capacity of the that will be more, we can control that purpose. We are using induction motor drives generally for the adjustable speed drives. Generally this is the general these locations generally we are using for the control of the speed. Next one would be servo drives. Here servo drives generally this type of drives used for servo drives where the speed of the motor requires very precise limited speeds. Speed says only particular specified speed is required for the particular application. Means this is a type of used in the computer propellers. Means what are the servo drives means with small fans generally we use machine tools, different type of machines. Robotics means is different of small size means small size motors generally we are using for these applications. That's why generally these are generally used for the computer propellers. What are the peripherals generally we are using computers, means inner type of inner operating motors, just fans generally. There's a inner peripherals of the computers and machine tools also we are using. Next, robotic operations, continuous operation of the robotics also we are using. These are the two types of drives, motor drives used for the different applications. That is the servo drives and this adjustable speed drives. Now here what are the factors affecting the speed of induction motor? Different type of factors will be affected for this control of speed. Means we don't know about the control of the speed, how to control that. That's why we want to know the control, what are the factors affecting for the speed of the induction motor. Means here we can go for the induction motor mainly considered classified two types. One is squirrel cage induction motor and slip ring induction motor. Here this in this each motor consists of starter and rotor. It have rotating part and stationary part. Means that is the stationary part is called stator and rotating part is called rotor. Here and its speed can be different ways varied in different ways, either by changing the starter input or by changing the rotor inputs. Means it have starter and it have rotor. Means we can change the that speed. Means by using starter or by using rotor we can change this type of motor's speed. Here speed of the motor means speed we can means generally this 120 f by p is a synchronous speed of the that motor will be operating at a 120 f by p. Means slip is will be ns minus n by ns. Now here normal speed means we want to change the motor speed. Means n is equal to, we can write it from the above slip equation. Means n is equal to ns into 1 minus s. Means this way we can vary the speed. Means rotor speed, this means n we can vary. Means either we can vary the ns, either slip, either we can see that from the ns equations f and p. That is also based on this one we can change the speed of the motor. Means either we can change this what by using whatever the inputs required for the starter or rotor, we can change to change the speed. Here from that one we can say that what are the factors affecting by changing the applied voltage to starter. Once we can change the applied voltage to the starter, we can change the speed. Whenever the supply voltage changes, we can know about next next topic. In this one only we can know about the how it will be changes by changing the applied voltage. That is the one cause for the factor affecting. That factor will be affected for the speed of the induction motor. Next one, by changing the frequency to the starter. Already we know that 120 by p. If means here n is equal to ns. Ns is difference means ns will be directly depends on frequency. Means by changing the frequency to starter, by changing the number of starter pole. Already we can so know that from this one ns n is equal to ns into ns means ns 120 by p poles, number of poles. Means by changing this number of starter poles. Next, by rotor rheostat control. Means we can change the rotor rheostat control also. Next one, by injecting an in the rotor circuit. Means separate voltage will be want to give to the rotor circuit to control the that speed also. Next, by operating two motors in cascade. This also means whenever you are operating the two motors in cascade, these are the major factors will be affected for the speed control of the induction motors. Means by using this one, whatever the applied voltage or frequency, number of starter poles or restart control, and injecting EMF into the rotor circuit, operating two motors in cascade. These are the general methods. These factors will be affected for the base when we want to change the frequency. Means these are the factors affecting for the speed of induction motor. Now, means here we are already studied different factors. Majorly we can know about the one or two topics for the how it will be changes. Means by changing the applied voltage to the starter we are discussing, means how it will be changes. We want to know about that one. Next, frequency, already we are discussed about that one. Number of starter poles, and this is how it will be changes. We know, we want to know about that one. By changing the applied voltage, first of all, from the torque equation of induction motor, T is equal to K into SE2 square R2 by under root of R2 square plus SX2 whole square. May K means 3 by 2 pi ns. We can substitute that one from this above equation. Already whenever we are designing the induction machine, once we are designing means we are not changing the what are the starter or rotor winding. Means that is a fixed, that rotor winding will be fixed. Means that resistance of the that winding will be fixed. Means rotor resistance will be constant. That is we are assuming here rotor resistance R2 is constant. Once we are designing means rotor resistance will be constant. If the slip S is small, we are assuming slip S is small. Already with 0 to 1 only, 0 to 1 only this slip generally we are considering. Means a slip already it is a small value. Means when the slip is zero point 0 to 1, it means 0.0101 means 0 to 1 only. This already slip will be very small. Small means this slip will be small means then SX2 in no, denominator means SX2 whole square it have. Means SX2 whole square value also too small, so that it can be neglected. Means R2 we can, it's a constant value, we can neglect, and SX2 whole square means very too small, means that's we can neglect. From the torque equation we can neglect that. Means here T SE2 K into we can say SE2 square R2 by R2 square plus SX2. Now here R2 will be constant. Now R2 square will be already it's a constant value, it will, we can neglect. SX2 value will be very less, means too small, we can neglect. Means here from this one equation T is equal to means SE2 square K into K, there is a total all are constant, we can T proportional to SE2 square, we can write it T proportional to SE2 square. That is the symbol is square of the symbol, that is square. This is therefore t is proportional to se2 square. E2 means rotor voltage, induced voltage, we can say that. That's a E2 we are mentioned this, where the E2 is the rotor induced EMF and E2 is proportional to, we can write it voltage. Means the torque will be depends on SE2 square. E2 will be proportional to V. Now here thus torque proportional to S V2 square, V square. We can E2 proportional to V means induced voltage will be equivalent to the supply voltage, that's the voltage. Means that torque proportional to SVT square, which means if the supply voltage is decreased, then the developed torque also decrease. Supply voltage will be increased, torque developed also increase. But here instead of providing the same low torque, for the same low torque slip increases, same low slip increases with a decrease in voltage, and consequently speed decreases. Slip increases means that is whenever slip increases means S is equal to ns minus n by n. Means whenever the, that is also possible. Slip increases means speed will be decreases. Speed decreases means automatically output voltage will be decrease. The speed, consequently the speed will be decreased, means decrease in voltage. Means there is a major problem for the change of the that speed decrease. Means it will be depends whenever the it will be depends on the voltage only. Means whatever the motor speed it will be changes, that will be depends on the induction machine generally. This is applied based on the applied voltage, means based on the that voltage this torque will be changes, that due to that one torque changes means automatically speed will be changes. Yes, will be change. Now we are here what we already we are discussing. For the same low torque the slip increases. Whenever the slip will be increased means automatically decrease in voltage, due to that consequently the speed decreases. Now here in this method easiest and cheapest easily we can say as still rarely used. Why? Because the large change in supply voltage is required for the rarely small change in speed. Why? Because torque proportional to v square. Square times it will be changes means one time it will be decreases or changes, one time changes means torque is proportional to inductor speed, means automatically means square time it will want to require, means large change is required for the voltage, but small change in the that speed is required. Torque will be changed, small change in the torque, that is related means due to that one automatically small change in the speed of the that motor. Now large change in the supply voltage will result in large change in flux. Large change in the supply voltage will result in large change in flux density. Hence, it will disturb the magnetic conditions of the motor. Whenever the large change in supply voltage will be occurs in the that starter, result in a large change in the flux density. Large change suddenly occurs means it will disturb the magnetic conditions, whatever the conditions of the that motor also. That is also major. That's why generally we are not using that much, but we can use it to present whenever you are using the proton device. We can use it by the method. That is the method of changing the applied voltage. Second one will be by changing the applied frequency also. Now synchronous speed of the rotating magnetic field of the induction motor is generally already we can know that synchronous speed ns is equal to 120 f by p into r and 120 f by p. Whenever the that is the proportional it ns proportional to f. So we are changing the frequency means it will be changing the synchronous speed, means hence the synchronous speed changes which changes frequency. Already we are mentioned this. Actual speed of the induction motor is given by n is equal to ns into 1 minus s. However, this method is not widely used. Why? Because every time we want to change the supply frequency is very difficult. That's why they're not widely we are using. Next, it may be used where the induction motor is supplied by a dedicated generator. Fixed means so the frequency can be easily varied by changing the speed of the framework. It's permanent. Also, a lower frequency, the motor current may becomes too high. Whenever it operates a lower frequency means the motor current may becomes too high due to decreased reactance. Whenever the frequency will be reduced, lower frequency means reactance XL is called 2 pi f. F decrease means the total reactance decrease and the current will be increased to I. And if the frequency increased behind the rated value, maximum torque developed falls below the speed rises. That is a major condition for this one. Next up, this is a major important one, constant V by F control of the induction motor. This is one more method generally we are using for the control of the induction motor. This is the most popular method for controlling the speed of the induction motor. Speed of an induction motor. And in this method, in the above method means same method what we are studied. The supply frequency is reduced, keeping the rated already what you are studying the voltage control. Same that method. Then the method supply frequency is reduced, keeping the rated supply voltage will be are maintained constant, and we can reduce the frequency. Due to that one, the air gap flux will be tend to saturate. Why? Because this cause excessive starter current. Whenever we are maintaining the supply voltage, this frequency when it is reduced, the air gap flux will tend to saturate. Air gap flux will be saturated. This causes excessive starter current and distortion of the starter flux. So therefore, the starter voltage should be due to that problem means whenever the air gap flux will be saturated, air gap flux will be tend to saturate due to that excessive starter current. Due to whenever the saturation means excessive current will flows and distortion of the starter flux will be occurred. To avoid that one, that's why therefore starter voltage should also be reduced in proportional to the frequency. So they to maintain the air gap flux constant, V by F constant means flux will be constant. There is no effect on that one. The magnitude of the starter flux is proportional to ratio of starter voltage and frequency. Hence, the ratio of voltage to frequency is kept constant. We are maintained. The flux remains. It will not disturb. The flux always it will be constant. Also, by keeping V by F constant, the developed torque remains approximately constant. Means there is no change of the this flux density constant. Flux constant means the developed torque also constant. Means this method is gives the higher runtime efficiency. Due to this one, we can maintain runtime efficiency will be more. These are the general different methods. General means not only the starter poles we can change, means one that the disadvantage. Why? Because once we are designed the starter pole changes, means every time we want to design means very difficult. That's why every time we want to change the particular motor means it is very difficult. That's why generally we are not prefer the starter pole changing also. These are the general methods for the this varying of the induction motor. Now here, speed control of three-phase induction motor using AC voltage control. First, we are using AC voltage controls. Here, this method, the output voltage can be regulated. Here, whatever the input we are given to the this induction motor, that we are controlled from the that AC voltage regulator. Means AC voltage controller. We are using AC voltage controller. We are controlling the output voltage of the this controller that we are given to the induction motor. Due to that one, we can control the speed of the induction motor. Here, this method, the output voltage can be regulated by varying the firing angle of the two thyristors at a time. Means here this regulator generally we are using. Means we want to control the whatever the output of the this controller means by varying the whatever the firing angle of the that circuit to control the output. That output we are given to the input of the induction machines. We can control it to the after up to required range of speed. Means here one thyristor from the odd group and one here we first of all we want to see this is the actual circuit of the converter control voltage controller feeding to the three-phase induction motor. Means here each phase you have two thyristors. It's the anti-parallel connection of the two thyristors. Here we are connected is the phase sequence of the thyristors 1 4 3 6 5 2. Here in each thyristor one thyristor will be differed by the three numbers, means three times, means T1 T4 in between the that will be three thyristors. We are means T3 to 6 three thyristors, 5 2 and 5 three thyristors. It will be difference will be three thyristors. It is it yeah. Means in this general general voltage regulator, just like it is a voltage regulator what you are studied in this one. Then means here we are using the voltage regulators, means AC voltage regulators generally we are using. AC voltage control, that's generally we are using for the control of the thyristor. Means main aim is already we are discussed about the different controls. So what these controls will be by changing the here by changing the applied voltage. That's a general way I can apply. That's we are applying means S torque proportional to ACT square. Whenever you are changing the voltage, the torque will be changes. That proportional to torque will be changes. The torque proportional to speed means the speed will be changes. So this method generally we are using for the control of the that speed. Now here we are not using changing apply frequency. We are not using wave control. So mostly generally we are using present situations. We that is efficient control. Now here we are using this voltage regulator voltage control. Here we are using voltage control means we are changing the applied voltage only, means applied applied voltage is the motor we are changing. Here voltage means that we can change by using whatever the firing angle of the particular thyristor we can change it. Actually this is a sequence of the what we are giving the thyristor numbers. We can see it from that one. We are giving there's a positive group means forward direction. T1, T3, T5 are positive group and T4, T6, T2 are negative, comes under negative groups. Here two groups, one is positive group and one is negative group. Positive group is T1, T3 and T5. Negative group is T4, T6 and T2. These are the different positive group and negative group thyristors. All are generally each phase have two thyristors is anti-parallel. We are connected. Here we can see here the firing angle of the two thyristors at a time. Means here what you are doing here, output voltage can be regulated. You can vary. Why? Because we want to vary that output voltage of the regulator means automatically that input we are given to the that induction machines. We can induction machine input voltage we want to change means this output of the regulator we want to change. We want to change means how you can change means based on the whatever the firing angle of the that two thyristors at a time. Means at a time means the three-phase induction machine means automatically closed path you want to give one phase to the another phase you want to give the closed path. That's why at a time you want to conduct two thyristor means it will be gives closed path for the circuit means which generally this sequence is designed by the whatever the phase which is more positive phase means that we are considering for the group 1 means positive group which is most negative that means most negative phase, that in that one negative group thyristor will be on, means more positive supply will be appear when now whatever we are considering the three phase supplies, whenever which phase will be more positive, that phase, that positive group thyristor will be on. Next one be which is more negative in the each that supply in the that more negative of the that phase negative group thyristor will be switched on. That is generally in that way we are designed the particular sequence of the thyristor numbers based on that one only. Means we are not designed generally directly, we are not designed that numbers based on that one, we are assuming that numbers as a sequence. Means we want to control that output, means we can control the firing angle of the two thyristors at a time. Here one thyristor from the odd group and another from the even group. The thyristor conducts in the sequence. That is we are this sequence we are mentioned based on that one. Six and one means six means that the thyristor number six. One means thyristor number one. That is the numbers will be we are mentioned for the that thyristors. 6 1 1 2 2 3 3 4 5 6 4 5 5 6 up on. It is a in this way we are switching on the means 6 means thyristor 6, 1 means thyristor 1, 1 means thyristor 1, 2 means thyristor 2. This is general sequence of the thyristors we are concerned. In order to obtain this sequence of thyristors are numbered with the difference equal to the whatever the difference is equal to 3 in each anti-parallel set, means difference of the thyristor we are placed here, that will be equal to the 3 number, equal to 3 in each anti-parallel group that we are mentioned. This is in this way we are, we can say that at starting means positive a means t1 will be t1 and already t6 and t already we are studied t1 6 and 1, 6 negative group, 1 is positive group, means it will be given to the cycle. Next 1 2 t1 the year and 2 will be this is a negative group of the c phase, means before we are connected to the t1 and t6, means this is a closed path we are taking. Next 1 and 2, one positive group negative group, one is positive group and next one next 2 3 c phase will be negative group and 3 will be positive group, 3 means b phase positive group, means positive 2 3. Next 3 4, 3 is positive group and 4 will be negative group of the different phases. Every time we want to connect in different phases we can connect, we want to conduct, means next t4 is connected, means 4 5, t4 will be negative group of the a and t5 will be positive group of the c, t5. Next 5 6 positive group the c phase positive group will be t5 and the 6 will be negative. Next 6 1, in this way the sequence will be continuous, and in this way means one is positive group and one is negative group, means that is in different phases, that is in different phases, means it we are connected, one phase will positive group, one phase will, in one phase will negative group, it will be conducted. In this way we are converted that input, we are controlled that input to the output, we can give it to the three phase induction mode. This is a general waveform of the speed torque characteristic as affected by the voltage. This is a full voltage when you are considering OAV is a full voltage generally. In that operating point will be torque load generally when you are where we want to low torque will be where we want to operate, means operating point will be A. Suppose speed that voltage you can mention here for low torque, for low torque T A is the operating torque point A at rated voltage, means rated voltage means K is equal to 1. O is the motor speed. For reduced starter voltage we are reduced, means K will be reduced to 0.5. B is the operating point. OB is reduced motor speed. Here we can see that means whenever the reduced means reduced voltage means full voltage when you are given the speed will be maximum speed will be rated speed will be OA and operating point will be for the low torque will be A point, we are operating point. Whenever the reduced voltage 50% means K is equal to 0.5, we are the OB will be reduced voltage, the 50% voltage means B is the operating point. In this way we are operated, we are based on this one we can control the speed of the that induction motor. This is the next, this is advantage will be smooth variation of speed will be possible and energy saving is possible. Why? Because circuits we are using means energy saving will be very, very less, it will be used minimum amount of energy for that one, energy saving will be more, we can control wide range of speed. Disadvantage, power factor is low, means less speeds when you are operating perfectly low, or means whenever you are converting that voltage AC into AC, means whenever AC conversion will be possible, in that time harmonics will be occurred. Electromagnetic interference also, due to this changes of that one, electromagnetic interference also occurs. Next applications, fans, blowers, centrifugal fans, different applications generally we are using for this induction machine. Next one will be speed control of induction motor using voltage frequency control. Means voltage want to control at a time, voltage and frequency we want to control. Based on that one, we can control the speed of induction motor. From this one you can see that the speed of induction motor may be controlled by operating them from a variable voltage fixed frequency supply. One is variable voltage fixed frequency supply. Second one would be variable voltage fixed frequency supply can be obtained by means of three-phase converter inverter circuit. Variable voltage fixed frequency will be generally by using voltage frequency control. Generally we are using, means here voltage variable, we are changing the voltage but frequency will be constant. Here generally we want to get it from that one, that variable voltage and fixed frequency supply can be obtained by the means of three-phase converter inverter circuit. Generally we are using this is the converter, three-phase converter. This six resistors, the numbering we are not mentioned, this is totally generally the way of the diagram we are mentioned already. We are studying the three-phase control, three-phase converters. Means this is a converter. First one will be converter with L and C we are mentioned here. L and C to the this inverter. Right side will be inverter, to the output we are given to the three-phase induction motor. Here we are using the converter. Same operation we are studying in the converters. Which is more positive, that thyristor will be positive group will be occurs. Which is negative, which is more negative, that negative group of thyristor will be occur. In that way, that AC voltage will be converted into DC voltage. That AC voltage will be converted into DC voltage. That AC is converted into the DC. Due to that one, whenever continuously that three-phase output will be, three-phase input we are given, that three-phase input is converted into the DC output voltage. That voltage we are given to the inverter circuit. Means when directly we can give it to the inverter circuit, but why you are giving the LIC circuit means some harmonics will be occurred, spikes will be occurred. You know, to smoothen that harmonics, means generally we are using the voltage ripples and current ripples will be occurs. You want to avoid that one. Why? Because if you continuously voltage ripples, current ripples, whenever you are given to the that machines, means loss occurred in that machine will be more. Our aim is we want to avoid the whatever the losses in the that supply we are given to the that motor. Means that purpose, whenever conversion will be done AC into DC, means AC will be, whenever conversion will be occurs, means that spikes will be occurs. That means harmonics will be occurred. You know, to avoid that harmonics, in series to that one L current ripples we want to avoid. C for the voltage ripples purpose we are connecting the L and C terminals. That output of this converter we are given to the inverter. Once again this will be converted into AC into the DC into AC. That AC will be given to the three-phase induction motor. Means why you are using the converter inverter means we can control the means wide range. Means directly only we are controlling the AC voltage regulator, means we cannot control the wide range. Now by using this converter inverter circuit, we can vary the whatever the voltage in a wide range, we can control smoothly, we can control. That purpose we are using this converter inverter circuit. In this way we are using. Here from the circuit, the three-phase converter will convert AC voltage into controlled variable DC voltage. We can vary the voltage. Variable voltage variable will be occurred at this converter also. This controlled DC is filtered by LC filter to minimize the ripples contents. That is the voltage ripple and current ripples. Then the filtered DC is fed to the three-phase inverter as input. As the input we are given to the inverter. By varying the firing angles of the inverter, bridge thyristors. Variable three-phase AC output voltage is obtained from the inverter side. Bridge which is fed to the three-phase induction motor for its speed control. Means here three-phase supply will be converted to DC. That DC once again is converted by using this the inverter. We are converted to that AC. Means here we can control how much, means wide range is possible. Here also we can control the converter when you are using the rectifier. We can control the output by using varying the firing angles. Here also inverter we are using the firing angles. Means based on that two sides, we can two ways we can control the that output voltage. We can control the wide range. In this way we can control the wide range of speed is controlled. This generally we are using what we are designed here, this this converter and inverter circuit. We can simplified manner we can mention that purpose we are using the circuit. That is, this is three place, here three phase supply we are given to the single, this is a three phase controlled converter. There's a next we are connected to the L and C. This is a filters generally we are designed here. Next inverter circuit means inverter, three phase inverter we are using. That inverter output will be AC, that is we are given to the induction machine. In this way this controlled converter and inverter circuit used to control the speed of induction machine. In this way we can control that speed of the machines. Okay, thank you.